Hello everybody and welcome back. Today I'm going to be trying to implement my solution on this little breadboard. It's temperamental to say the least. It's not the highest quality of breadboards, but it should do okay. I'm going to try and implement it on this, we'll see how it goes, and then we're actually going to throw it on some of the green boards. Okay, quick high-level overview of all the components I'm going to be using for this. We have a potentiometer, I've got a 24 volt power supply, a 5 volt power supply, these little transistors, I believe they are UA74 1CP. Those are my op amps. These guys are my little transistors for getting some more current. And yeah, so transistors basically give me a voltage from a control and allow me to do as many circuits in parallel as I need to without losing voltage. And then these guys give me the rest of the current that I need because I will overcurrent an Arduino if I use just straight current. The components themselves just won't handle the volume. So these pots are not happy. This guy will definitely not handle the full volume. So that's kind of the high level. So a super high level of everything that we're going to do. Essentially, we're taking a control voltage from the potentiometer. We're going to throw that into a transistor, which is then going to use that to give it a voltage between 0 and 24 volts. That voltage is going to go into the circuit, into the parallel LEDs, and we are going to use a resistor to control the actual voltage going into the LEDs. And then essentially that just gets grounded out. But like I was saying, we can't actually do 25, etc. LEDs on a transistor. So, or at least that amount of current, they're just not rated that high. So we're going to use these little guys and use those for getting the additional current that we need from the power supply, and yeah, should go good. So here we go. Okay, first thing I'm going to do is actually make this top rail 24 volts. Stick some power in there. Good start. Keep those relatively tensioned just so that they're out of the way. Okay, then I've got my 5 volts. And then we'll essentially grab power on these middle rails as needed. Don't need them yet, so we're going to leave them off for now. So the first circuit I want to do is literally just a simple single LED. So we're going to use this one. And we're going to put our LED voltage into the top and our ground into the bottom. We're going to do that on all of them. That way I can plug in as many LEDs as I want, and I really only need one control voltage that's been through a resistor into the top row and then the bottom row. So, in order to facilitate that, I'm going to need a ground, but I'm also going to need a jumper across the sides. So we're going to grab a whole bunch of these little guys and do some jumpering. I think just to make life a little easier, I'm actually going to straighten out these guys and just put them in like this. Then we're going to use this top one for a control voltage, and then this bottom row is going to be specifically for the LEDs. So I do need to jumper that control voltage. We'll use yellow. Alright, so now I've got a control voltage lane. Let's grab our ground, pass this up, because we are going to need a universal ground pretty much on everything. Let's actually move this down to the end. Actually, no, you're good there. And I'm just going to jumper it across like we did with all the others. Okay, so as far as the setup, we've got ground all the way along the bottom, 5 volt rail there, positive and negative for our 24 volts. We have a control voltage, and actually I'm going to use, this does need to be moved, but I'm going to use a yellow one for that. So our control voltage, no matter where I put this potentiometer, which I might put it over here, not a bad idea. We're going to put that over there. And then we're going to do power. I'm actually going to need it all the way up there, but we're going to do power into this lane, ground into this one. Then I actually need a resistor where it's 600 ohms from ground. And to do that, we're going to use a 100 and a 470, which is going to get us close but not perfect. I will need to actually order the correct LEDs at some point. That will be ideal. So we're going to jumper this guy from here, just somewhere over here. Nice bend, thanks. Then we are going to use the 100. We could do 5 of them on the 100s and get an actual, or 6 of them, and get an actual one. But I'd really rather not. That's a lot of resistors just for this. So eventually I will have the proper number, but I gotta order them. On this one, I'm gonna pull off a single 100. We're gonna jumper that right. Yes, that is tricky. Very tricky, because if I put that there, then I gotta use that guy with that there. Have just that little stabby. That should be okay. So we're gonna go right here and right here. And then we're gonna jumper power. This is still 5 volts, so we're gonna still use this red. Then we are going to, off by 1, plug this guy in. I do need to jumper that control voltage. Oh, that's way too far. That's okay, we can do it diagonally. We're gonna go control voltage to control rail. This is essentially gonna be the output of this potentiometer going as an input to literally all of my other circuits. That's gonna go there, and then as I adjust this, that's gonna change the control voltage, which is then going to go into our transistors. We no longer need that wire. So then we've got our 2 test cases of 1 and 4. So now we get into the transistor. So we are just gonna plop that guy in right here. And actually it's the transistor output that I need. So you're gonna go over here, potentially, and then the transistor, the output of this is gonna be jumpered into that rail. So I'm gonna take, we're gonna use white. Do I have enough? Probably just gonna jumper that with one of those. So it doesn't really matter too much where we put these two. Although it is nice when we can get the transistor plugged in and working and everything else. And the transistor needs both a positive and a negative, if I remember correctly. So it's going to take in 24 volts, take in a control, and then output a certain number. And that output is going to go into a resistor, which is then going to hop into this rail down here to power the LEDs. And that control voltage is going to come out of this transistor. And it's basically just going to forward that voltage with a current. Never good when you get a bent leg on a transistor. So actually, the output is 6, which is the top one. So we're going to take the output, which is going to be green in this instance for whatever reason. We're going to wire, put the transistor there, or the gate, I forget what to call them. You go there, then we're going to put the output, which is pin 6, lined up with that. That way our output is just going straight into the pin. Now we're going to wire 2 of these, set up a second one, also use green. Then I need to give you power, which means we're going to grab a red from the top rail. That goes into 7. I hope if I put down my little transistor, same orientation, perfect. And then right here. Alright, there's power. Then we're gonna need ground. And unfortunately, I need this ground, which means I think we're gonna just make this one the ground for our 24 volts. Then I can just grab this. We can bridge ground. Well, V negative, which is pin 4. We're gonna bridge pin 4 and V negative. Another pin 4 and V negative. Now our transistor also needs power. Unlimited power. It's gonna get power here. The input, and then that is actually gonna go to our LEDs in just a minute. And here's your power to draw from. Now this power is essentially going to be bridged down into this by different resistors per LED cluster. So, let's finish this guy real quick. You're going to need a control voltage into the non-inverting input, which is number 3. You're gonna go there. This non-inverting input, pin 3. And then our inverting input is literally gonna go straight to ground. I don't know if this is a true ground. I think this is actually the negative, which means to get a ground, we do need to come all the way down or attach to this one, but that's a little longer. So I'm going to use one of these black ones, makes it a little less clean, but it'll do exactly what we need. So this is our V negative inverting input to ground, and our V negative inverting input to ground. Alright, what do we have left? So our inverting input, that's our non-inverting input, that's our voltage, negative. We're not doing an offset. We have our output going to our transistor. We have our 24 volts in, and then we have a non-used pin. So that's all of this guy. Now we have to take the output from each of these, run it through a resistor, and then plug it in so that way we can pass voltage into these. In order to do that, I'm going to move this up a little so we can grab the one from the bottom. Or I could literally just do the smart thing and just plug it up higher. I don't know why I didn't do that on the other one, but good enough. So our resistance, 1.22 kilo ohms. Makes it super easy because it's a 1K and a 220. So here's a 1K. Sorry, that's a 220. Here's a 1K. Now that is going to go into our positive voltage for our LEDs. So that will essentially feed power to the LED. A whole lot of hops, skips, hoops, and jumps. Alright, next one I need is 305 ohms. Do I have a 305? What's the closest? There's a 300. Then I would need like a 10. It's a 330. I don't have a 5, but I have a 300 and I can throw a 10 on there as well. Actually, I underdid the voltages, so a 300 will not cook it. So we're going to use a 300 all the way down into our input voltage for our LEDs. Now, that should be everything. We're going to turn you to about half. That way, if no matter how it's wired, it shouldn't pop anything. Let's hope nothing pops, and here we go. It's one LED on. That's pretty terrible. So unfortunately, I think this is a breadboard problem, which is really annoying. Because I betcha we keep jumpering stuff and getting closer. We'll start getting closer results. Could also be the fact that we used a 330 or 300. Although going down increases the volt or the current, so it should actually have the opposite effect. Well, ooh, what to do? Measure everything. That's what we do. I'm gonna move this over slightly. So, what are we getting and where? 24, 24, 24, 24. Okay, so my voltage is coming through. Let's see, passing in 1.9 volts. It's passing in 1.7. 1.7 over there. It's 1.9 in the middle. 2.1. Okay. This is producing 2.1. It's our control voltage. 1.6 control. 1.6 control. Still 1.6. 1.6. But the outputs are different. That is most unfortunate. That's 2.16. 1.9. So this transistor might be bad. So I'm gonna unplug it. I'm gonna try another one. The other problem is the breadboard might have more resistance than, let's just say, advertised. We're coming out with 1.9. So that's better. It's making a better connection, but it's still not making a great connection. So I think in order to get this to work, it's 100% on this guy. I think in order to get this to work, I'm actually gonna have to solder everything. So I'm going to solder these chunks onto a breadboard, something I can actually use later as well. Well, that's max brightness. So I'm going to get to soldering, and I'll see you guys in a minute. Quick time lapse. Okay, I have a 3 and a 7 LED to do for my next couple panels, so I'm going to make these guys and actually solder up a 3 and a 7, and we'll start there. So, on to it. Alright, I'm going to cram as much of this onto a little board as I can, and since the only difference between LED circuits is just the resistance that goes into it, I'm just going to essentially wire up a couple of them and leave space for anything that I need on them, and we're going to start there. So, on to the soldering. Okay, this is my little circuit for a 3 LED. Let's plug it in and make it work. So, green is my output to go to the LEDs. Yellow is my 24 volt high. White is my 24 volt low. this is just standard ground, and then blue is my control voltage in. So let's wire it up and see if it works. So control voltage, I'm actually probably gonna pull a bunch of this, but I do want to remove, well, that's not needed. Powering the LEDs. This is gonna be my control voltage, the one in. This guy is the high voltage 24. You are the low, nope. You are the low voltage, and then you are ground. And then power to the LEDs actually comes from this guy, which is receiving power. So technically yellow's my hotline. Let's plug it in and see actually. So we're gonna turn that off, we're gonna turn that on, and we're gonna plug in our power supply. Not promising. Ground, control voltage in, negative on there, positive on there, just not getting it. It's unfortunate. Look, it's probing time. All right. Oh, that's why. This does have to be down here, and this does have to be grounded here. There we go. Our 1 and our 3 are lighting up the same, and they go all the way up, and all the way down, and all the way up, and all the way down. Sweet! That's one good circuit. That's phenomenal. Yeah, it does help if you actually run a ground to the potentiometer. But that is the first circuit for a 3. Essentially, as I go on, I can just make more of those and just change the resistance value to whatever I need to in the future. Alright, so I do have to get a couple of things before I can really truly integrate this into the cockpit, such as a 5-volt supply in addition to my 24. So when those parts come in, I'm going to tack them on. This is all going to go in the cockpit, and we are going to have a pretty solid setup. I'm pretty excited about this. So hopefully you guys enjoyed watching this and you guys got something out of it. If you did, definitely like, subscribe, and if you've got any suggestions or improvements on how I can do this, or even how I can organize the boards, definitely let me know, and we will see you guys in the next episode.